Okay, so I got to make sure we're on the air here. Sorry about that. Yes, we are. All right, my bad. Okay, there we go. All right, so here's what's happening on the vacuum can. Now, I didn't really watch that vacuum cannon thing that I had you all. I hope it's interesting. We've shot this thing through Coke cans because they get going fast. And when you probably went to that video, they probably showed a bunch of other videos of watching the vacuum can. It's just amazing to me because I remember back, all these videos that we have to really show science. I'm supposed to be able to go to this, but I want you to watch the train car getting smushed, and then that third video of the young lady in the science project. Why does that can get crushed? If you listen to the young lady in the science in the video that's doing that little science demo for her class, you boil the water, okay? You boil the water away. You don't need a whole lot of water in there, and that creates steam. All right, so that steam creates pressure on the outside of the can. Okay, so that steam it's the molecules are moving around much faster, which creates, and that collision of those molecules moving fast on the inside of the can is steam, is what causes the pressure. All right, and then what did they do? They put it in the pool to cool it. There's probably a pool of ice water. All right, and then they probably should have put it sideways and started spinning it. If they'd have put it sideways and started spinning it, then what would happen is that steam would cool on the inside. The pressure on the inside would go way down because the temperature on the inside went way down, okay, lowered quite a bit. So therefore, the pressure on the inside was much less than the pressure on the outside, which crushed the can. With the rail car was split because it had all those fumes. There was probably gasoline that was in that car, and when they got sucked out the gasoline, they created a vacuum in there of gas vapors, which are much less dense than the air outside, and boom, it collapsed. So the reason why does the can get crushed? It's held upside down? No. The metal was quickly cooled down. No, not the metal, the air was quickly cooled down. The pressure inside the can decreased? Yes, it did. The pressure, okay, so it's C really is why that worked. So before, after, no pressure on the inside, boom. And now density, we're going to deal with density here, and that is mass over volume, okay? And I will work through you on those pre-lab problems that we have. Density is mass over volume. So this is pretty funny. Physics professor Ray Brown discovers the white dwarf star fragment that will turn out to be the missing ingredient in his miniaturization device. I think this is the flea or the fly, or not the fly, but the Atom Man. What's his name? From Kansas City, the actor Paul Rudd. I was going to say, wait a minute, it's Paul Rudd. Married to Olivia Wilde. I mean, no, that's Jason Sudeikis. That's the other funny guy from Overland Park. Sorry, I'm getting my Kansas City celebrities mixed up here. All right, so anyway, what would be the density of a white dwarf star? That's what comic books are kind of funny. Assume the white dwarf fragment is a sphere with a radius of 6 inches. I make you do this, not this particular problem, but I make you find the volume. We're going to find the volume of a baseball and things like that, okay? We're going to find the volume of a baseball and maybe or of a golf ball, see if it floats, all right? Because when things float, they're less dense than air, which makes them float. But anyway, so we take the volume of this thing. Ooh, that's an ugly-looking formula. 4/3, basically all you do is do 4 divided by 3 times 3.14 times the radius 3 times. We got to turn this radius into meters, which we do, which is 0.15 meters. It's so easy with Google anymore. You just go inches into meters. Boom. Gives it to you. 6 inches is how many meters? Bang. It'll give it to you on Google. You don't believe me? Watch. Watch this. Watch and learn. Watch and learn. Okay. So that's processing done. Oh, I got to come back to that in a minute. All right, so here we go. I think mine's set on Yahoo for some stupid reason, but inches to meters. You just go to inches to meters. You go, okay, 6 inches. Ah, I screwed that up. How did I mess that up? Six inches. There it is, 0.1524 meters. That's how easy that is to do. Okay, and so when things are less dense than air, guess what they do? They float. Okay, they float. I'm going to go ahead and load some of these films that we've already made now, and so we're done with track 4 here. As soon as I find it.